Okay, so the instructions would say to factor.
Mm-hmm.
This is the a equals 1 case.
Yeah, and that's where you don't multiply the number in C.
You do not. You can. It actually still works, but you don't need to. It's like a necessary step. You're trying to find two numbers that multiply to +4, but it's this right here. That's what it's +4, and add up to this +4, which this is a bad example because this is actually called a perfect square trinomial. So the short of it is you have to find the multipliers of 4. So 1 and 4, 2 and 2, and you ask yourself, do any of these add up to?
So that is the best way to do it, is by writing like 1 and 4, 2 and 2, 3 and 6. Okay.
Yes, until you know it so well that you obviously don't need to. You just see it and you do it.
All right.
So in short, this is
two.
Yeah, this is t plus 2 times t plus 2. Maybe these are all perfect square trinomials. No, they're not.
I know we were doing stuff where it's like
actually
it would be like 4t2 and like all the numbers are different. Like we've done like all of it.
Okay. There's about depending how you label them, somewhere between like 6 and 10 types of factoring. So let's look at this one here. Wait, I'm sorry. This one is not possible. Sorry.
Are you saying why that one isn't possible?
Sure. So let's go through what we just said. Write out all of the things that multiply to 20. And you want to do this in a way that's organized. So like the numbers on the left get bigger, the numbers on the right get smaller. So I try 1, I try 2, 3 does not work, 4 does. And you stop when you overlap. Like, see how the next one would be 5 and 4, and you already have that.
Yeah.
So you don't include that one.
So then would it just jump to like 2 and 10? Oh wait, that's already a thing. 10 and 2, you already have that. So it just ends at 4 and 5.
Yeah. So do any of these add up to
10?
10. The answer is no.
And
this one is considered prime.
All right. So what would you write for that? Just not
prime.
Okay.
Not factorable. So prime means not factorable. Yeah, and that's the same. That's the same. Same thing there. Okay, so let's look at another one here. These are all perfect square trinomials that actually do work. It's an odd way of doing this. This one requires a rewrite step. So the more math you take, the more you have to reorganize things. So you generally write these in descending order. T squared, T1, T0 power, that's descending order. And you put your C here. So C is the number. It's not the last thing that you see on the right.
Mm-hmm. So C won't have a letter.
Say that one more time.
So like C doesn't have a letter.
Yes, that's well, yeah. I mean, yes, that's kind of a, we have most for these.
I guess 1 and 25, 5 and 5.
Right. And then that's it. So do any of these add up to 10?
Yes, 5 and 5.
So that's your answer. That's the T plus 5 times the T plus 5. So actually all of these that you're doing are called perfect square trinomials. I want to just, I guess I'm concerned that you don't know how to do like something like this that I'm about to snip in. That's kind of the same type.
Okay, so I guess you'd have to A is 1, so it'd be
That's right.
28. So 1 and 28, 2 and 14,
Good.
4 and 7, and
Very
that'll
good.
be the answer.
That's it. So do any of these add up to 11?
4 and 7.
That's right. Okay. So you do know how to do this. Okay. The sheet you handed me, let me just grab these and snip these in. These are all what are considered, these are all like in the category of like what are called perfect square trinomials.
Mhm.
And these are done kind of a different way than the way we've been doing them. So have you heard that word before? Perfect square trinomial, that phrase?
I think just today.
Okay. And right, so this is really disorganized the way it's been presented to you. So okay, let's do a few more of these. I'm trying really hard to figure out how to organize this to best help you, but let's just do a couple more of these and then we'll move on to the A not equals 1, because those are the harder type to do. Okay, so here again, there's a 1 here, it's A equals 1. So you write this 36, and normally you would write like 1 and 36. Okay, but do you see how there's a negative here?
Yeah.
That means either that means to get to a negative, the one's negative, one's negative, because it has to multiply to 36. So they're either both positive or both negative. Since it has to add up to a negative, they have to both be negative.
Uh-huh.
Do you follow that?
So you always write both. When there's like a negative, you always have to write with it like negative like that.
Yes. Yes, for this type.
Okay.
So then it's like -3, -12, -4, -9.
Okay.
Negative -6.
-6.
-6.
Negative.
Whenever they're right next to each other, you're done. So do any of these add up to -12?
-6, -6.
Right. So it's t minus 6, t minus 6.
So then minus. So then you.
This is it. You're done here. You're done here.
Okay. What do you do like? So would you later for like a future problem go like t squared?
No.
Minus.
No.
Or is that like that's
something different? Yeah.
Okay, because I feel like I was doing something where it's like I did a little bit more past that.
Yeah. Yes. So this is let me go to what you've sent first, and let's try. This is truly like its own lesson potentially today. So let's see if at least these you can get when we're all done. So this is now factoring A not equal to 1.
A not equal to 1. Okay, so you have to multiply 4 and -3, which is
4 and -3, which is -12. So now this is where it's harder. To get -12, that means you have one positive and one negative. So it's like -1, +12, 1, -12, -2, 6, 2, -6, -3, 4, 3, and -4. Now, if it were my classroom, I would make students actually write all these out, because I think this is a very valuable skill to be able to do this. Figure out all the divisors of that number. Do any of these add up to 4?
-2 and 6. Oh, now I see why it's so like important to write all of them like that.
Yes, because you might think, oh, it's prime. Like, well, maybe you didn't find it. So this plus 4x becomes -2x plus 6x. That's why you do this on the right, all this stuff on the right. You bring down the other two terms.
So then
this is where you do a little
that
bit
would
more.
become 4x squared, and then that just is your answer.
No. There's more to do.
Oh, okay.
So now this is actually a factor by grouping problem. What is the GCF of 4x squared and 2x?
2.
2. And then how about,
Oh, x.
good. So what goes in parentheses here? Like you're dividing both of these by 2x.
4x squared and negative 2x.
So I'm going to write the correct answer and you can verify that. 2x times 2x gives you 4x squared. 2 times 2 gives you 4x times x gives you that. 2x times negative 1.
Divide it all and then put it in.
Yes.
Okay.
Okay. Now this is key. Whatever's in parentheses, you immediately write over here with a little space in between. You have to figure out what goes in this space. What goes in this space when you multiply by 2x gives you 6x, and when you multiply by -1 gives you 3. Any idea what goes here? Like what number? Maybe the number's easier. What do you multiply 1 by to get 3?
3.
3. Okay. And it's positive. So does this work? Is it +3? Like check that. 3 times 2x is 6x.
6x
3 times negative is -3. That works, right?
And then you'd look at it as if you were, the second part, as if you're like dividing it.
Sure. That, but like this 2x -1 over here on the right is because it was 2x -1 over here on the left. Okay. Then you grab the 2x plus 3. You grab these, and then you write 2x -1 because you're factoring again, basically.
So then 2x plus 3. So you
see where the 2x came from?
Yeah.
Like the arrow, and the 3 came from, and then you're basically factoring 2x -1 out of both.
Parentheses. So the parentheses like that always supposed to be the same?
Yes.
Okay.
Yes.
So that makes it easier.
Don't worry, we're going to do a bunch more of these on this page.
And then you go, wait, my final question for that would be, do you go like 2x times 2x becomes 4x squared, 2x?
No. You're making, what you just said is like making 4 right turns. You get back where you started.
Okay.
Like our goal is not to get back to the original. This is done. This is done right here.
Okay.
This will make more sense when you do a few more examples.
Okay.
And we're going to do that.
Did you get
it? And I'm sending the notes out right after the lessons. I'm not waiting anymore till the videos upload. So you'll get these right away. But I would still encourage you to copy everything down that you can.
Mm-hmm.
Okay. So step number 1 is you take this 8 and this 9 and you multiply them together.
8 and 9. Okay, 72.
That's right. And then hopefully, you're able to see that, okay, there's a -18 here. That means both of these are negative. And then you got to start finding these.
I guess -6 and -12.
Right. Now I did this for you. Do you feel like you could do this on your own?
Yes.
Okay. For most students, it's very slow and it's very time consuming. So just consider that as well. So yeah, these work. So this -18w is -6w minus 12w. I'm taking these two numbers and I'm appending the variable there.
Mm-hmm.
Then I'm bringing down the 8w squared and the +9. This is a complete rewrite step. It's a rewrite with this information on the right, but it's a complete rewrite step. Like there's nothing, we haven't done anything yet.
All right.
Okay, so now you look at the first two. What's the GCF between them?
2.
2 and letter?
Or parentheses, W. Parentheses 4w minus 3.
Good. Okay. Now you immediately write what's in parentheses over here.
4w minus 3.
And you figure out what goes in here such that when you multiply it in,
it goes into both of those. -3 because it's -12.
Very good. And then this is maybe the hardest part. Do you see how both of these have a 4w minus 3 in them?
Uh-huh.
You factor that out. And then what's left over? The 2w
in the -3.
and the -3.
And then it's done.
That is considered done.
All right. Okay, this isn't like too many steps.
I'm going to give you a totally workable problem on your own here. I want you to try this on your own and do it exactly the same way we just did, if you can. And I'll just give you 2 minutes here. And if you can't do it, that's fine. But I think you can. And then we'll work it out together if needed.
For in the parentheses, would I write it as like 4b plus 6b, or
You're breaking this apart into 4b plus 6b.
okay.
And then you got to find the GCF here of these.
Okay, thank you. So then, okay, I think I got it.
Okay, so let me keep working it out here so you can see it. Becomes b plus 2. Then you immediately rewrite b plus 2 over here and plus 6 on the outside. So it becomes b plus 2 times 2b plus 6. That's your final answer on that one.
And that is exactly what I got, which is good.
Great. Great. Let's move you to, let me just check one of these. So some of these could potentially be prime. I don't want to do an exception quite yet. Let me just check one of these before I give you the next one for us to do. You have this in front of you, is that right? Like you're visually seeing it?
Yeah, I'm seeing everything. I got it on my paper. I got it all.
Okay. Sometimes students they don't have it. You know, they took a picture of it and left it at school. All right. This one does not work. 8x squared minus 5x minus 10. Okay, let's do. Sorry, let me just get one more here. Check this.
Oh, good.
Yeah, let's have you try number 8 next. Number 8.
Is it on your screen or is it?
No, let me. That's why I asked if you had it here. I'll snip it in here.
Okay.
There it is. Okay. All right. So number 8 here. Give that a try on your own, please. How are you doing on this one?
Good. I'm almost finished. Okay, I think I just finished.
Okay, so what did you put here in the middle for 7m?
Minus 2m plus 9m.
Minus 2m plus 9m minus 3. Okay, so let me show you something over here, because this is how you did it, right? And you didn't do anything wrong, but I'm gonna just, let's just say you said, oh, I'm gonna do 9m minus 2m minus 3. Okay, it actually works out the same way. So 3m is what's here. You're gonna have a different thing here. Just go ahead and follow this on the right. 2m plus 3. So immediately put over here 2m plus 3. This is minus 1. So maybe in a different order, but did you get 2m minus 3, 3m minus 1?
Oh, wait a second. I have one more step left.
Oh, okay.
3m minus 1 parentheses, and then I'd have 2m minus. Okay, what I got is 3m minus 1 and 2m minus 3. So I don't know.
So let's look over here at yours then. So 2m goes into both of these. Do you see that? So it's 3m
plus, I mean minus m.
Minus
1. Yeah, just 1m. And then.
Okay, and then you immediately put it over here 3m minus 1.
So then it would be.
So 3 on the outside. So see how you pair these together? 2m plus 3 and then 3m minus 1.
Yeah. I had it as negative 3 on the outside of the parentheses.
Okay, but do you see now why it's plus 3? Because you're trying, if 3 times 3 gets you to 9.
Yeah, and then you have to keep it as negative 1. There?
Yep. So is this clear?
Yeah, it's clear.
Okay, let's do another one here. We'll do it together.
So, wait, what's the difference with the other one exactly?
There's no difference. See how the answer is exactly the same?
Oh yeah, I guess so.
That's what I was trying to show you. And I think I should have delayed doing that. So let me grab another question here from your thing. Let me just check it first.
All right.
Make sure it actually works. Some of these don't. All right, so we're gonna look at 9 next. I'll snip that in. Okay, so again, a not equal to 1, so you multiply 10 and minus 20. So that gives you negative 200. So that's quite large. There's a lot of them here. We want something kind of close together, 17 together. I'm going to help here. It's negative 8 and 25. Okay.
Okay. So then.
Okay. So this becomes 10d squared minus 8d plus 25d minus 20.
Minus 20.
So give me the GCF between these two.
2.
2d.
Yeah, 2D. I don't know why I don't ever say.
Well, hopefully you're writing it. So give me what goes inside parentheses here.
5d minus 4.
5d minus 4. Perfect. So you immediately write that over here.
4.
And you got to decide, like, it doesn't matter to me which one you do, because they both are the same, but like, you got to pick the one you like. Are you trying to get to 25d? Or are you trying to get to, the other one? And I guess I prefer the positives.
Yeah, that's what I do.
So it's plus 5.
Plus 5. So then you'd get 2d plus 5 and then 5d minus 4.
Exactly. So this over here on the right could be a really long step. Go ahead.
Do you write 5d minus 4 first or 2d plus 5 first?
It does not matter. It truly does not matter. Like, is there maybe a preference? Like maybe slightly. I would never mark you wrong for that. It's like it's a very small thing. If
okay.
it is.
Let's know.
Let me check one more of these. Next one here, 10. I think 10 is okay. Yeah, it does work. Okay. So let's look at 10 next. I'll have you try this one on your own.
All right.
And we can move on to some vertex form stuff as well.
All right. I'll start writing that down and then get to you once I finish.
Let me mute you for just 30 seconds here.
Sounds good.
Zach, just let me know when you think you're done with this one.
Sounds good. Wait a second. I have a question. So if it's negative 17,
Mhm.
are all the numbers just negative?
Yeah, so when you multiply 6 times 12 and get 72, the only way to get a negative here, when you're multiplying to get a positive, they're either both positive or both negative. So in this case, they're both negative.
Okay, sounds
That
good.
makes
Thank you.
sense.
So then, okay. Is it 2a parentheses 3a minus 4 and negative 3 parentheses 3a minus 4?
You give me the final answer on that? Sorry, can you give it to me one more time?
2a parentheses 3a minus 4. Oh, wait. I didn't get the final answer yet. I
Yeah,
keep
that
forgetting.
that's yeah, you're almost there. I almost call these like double factoring because you got to do it twice.
Okay, now I got it. 2a minus 3 and 3a minus 4. Or is it
2a minus 3, 3a minus 4? Yes,
well,
that's
okay.
correct. Yeah, let me just get that in here in case you look at these later.
Yeah, I need to like make a little note to myself, like one more step.
It's kind of like, you know, when are you done? When am I done? When am I done? When am I done? And that's hard because you're not done until you're done.
Yeah.
So let's do one more here. I think this will work. I like, I guess this one's not readable. 60. Yeah. Okay. So try that's yeah, you can read that one. Give this one a try, please.
All right. 14.
Yes. What two numbers are you multiplying together for this one?
I guess 6 and -10.
Okay, I'm sorry. I was just asked that first part. Yeah, it is 6 and -10. That's right. Okay.
Yeah, I was doing the negatives in the wrong place. So I had to take a moment there. $12. Wait a second.
This one definitely does work. You've already told me the right set of steps here. 12y
Yeah.
squared plus 6y minus 10y minus 5.
Oh, wait 1 second. I did a step wrong. Okay, what I originally did was instead of writing 6y, I wrote 3y, but now I have as my final
Yeah. So
answer.
if you don't get the GCF right, you have to
Then
keep doing it until you get the right GCF, because if you move the wrong thing over here, it'll never work out.
yeah.
That is one of the like hurdles here to this approach. So
then
hopefully
I
you get
got
something like
6y minus 5 and 2y plus 1.
right. Okay, so in terms of that worksheet, that the 8-6 practice, I would encourage you, if you don't already do this, to use something like Wolfram or Mathway or whatever online calculator you like to either check or know, like does it factor or not. Like you're not cheating, you're just making sure that, like, does it actually work? Like, you, like, if you know the target, you know where to go. So, and I would recommend doing more of these, but we should move to the worksheet 3, the kind of the factored form, vertex form, stuff like that,
Mhm.
and look at some of those questions there. So let me, I guess, give you a graph, and we can look at it together.
Did you eat my nerd?
Yeah, just a moment here.
Sounds good.
I'm just trying to get one that works
Yeah.
somewhat
I don't know how
nicely.
you find them all so fast.
It feels slow because I'm trying not to short your time here by me
Yeah, of course, of
messing
course.
around with stuff. But yeah, so let me grab this. I don't like that. Let's see. Let me look at one more time at what you're trying to do, so I don't maybe get too complicated here. All right.
1 second.
Sure. Still isn't working out. Okay, there's one that works nicely. Okay.
Okay, I'm back.
All right, I'm here. I've got one to snip in, and we can look at some of the features here that we already talked about here. So this is a parabola.
Wait, sorry, you're talking right now?
Yeah, so this one has this one is a parabola, slightly different than the one on yours, but it just opens down instead of up. So this is probably, we'll start with vertex form because I think that's easier. Okay. The vertex is either the min or the max. So it's either the min or the max, depending what it is. So see how this has a max right here?
Yeah.
And that occurs at -1, 9.
Yes. Min or more. And that's like the more.
Yeah, so there's more than that. The next one is the Y-intercept. So where does it cross?
It crosses at 0 and 8.
0, +8. And then the next ones are the X-intercepts. Now that's what I was struggling here. I was trying to find one that had all these nice
Oh shoot, are you
I'm asking you, yeah. Do you see them down here?
all right, yeah, my connection's just being a little weird. You keep cutting out.
So the first ones here at, like, it doesn't really matter the order, but can you give me those two ordered pairs?
0 and 2 and -4 and 0.
So the way you said the first one is would be up here 0, 2. It's 2, 0, right? The X comes
Oh,
from,
right. X-intercept is
and then -4, 0.
yeah, -4, 0.
Okay, and then the next one here is the axis of symmetry. So that actually is done after you do the vertex, because it's the well, actually we didn't, it's -1, 9. It's the X value of the vertex. It's X equals -1. So there's this line, X equals -1, and it's like a mirror. It's like, if you look at it, the left side is the same as the right side.
Is
Okay,
it what's the one where it's like a line below, like exactly one below, it's the lowest point of the graph?
well, the vertex is the min or the max.
There's like a line that goes across the graph, like sideways.
That's something else. It's a directrix it's in another in another context.
Okay. So I don't need to worry about that.
Nope, not in this, not here.
Okay. So which one we're doing exactly right now?
Just, is there anything else here that's unclear? Because the next one is called f of 0, and f of 0 means that X equals 0.
Okay, so f0 is X equals
So, and it's
0.
the same thing as this. It's the Y-intercept. I guess like they're the same thing. Maybe we need to like talk about that just a tiny bit more. But they're exactly the same thing.
Okay, that sounds good to me. X0, F0. And okay, all right. I think I got that.
Okay. So so f of 0 is 8 because when x is 0, like it's this point right up here, which is the same thing as the y-intercept. They're exactly the same.
So the f of 0 and the y-intercept are the same.
Yes.
Okay. Is it
Now
always
these
the
down,
same?
yes, they're always the same. Now these down here, these are x-intercepts, and it's and these are when f of x equals 0, f of x equals 0. They're kind of related to that.
All right. So x-intercept and y-intercepts is fx equals 0.
The x-intercepts is when f of x equals 0.
Okay. And that goes same for the y.
Yes. The
Okay.
y is f of 0.
So then what do you do next, I guess?
The next, I think that's it for this. Yeah, that's it for that. We can do domain and range.
Okay.
So the domain is always all real numbers.
Mm-hmm.
And the range, it depends on whether it opens up or
It's like
down.
y is greater to less than the
Oh yeah,
same.
that's right. You do it this way. I'm sorry, I forgot.
Yeah, no, it's all right.
It's x such that x is an element of the real numbers, comma, that's it. So that's everything. And then for the y, so the y is y such that y is an element of the real numbers, y greater than or equal to k, and k, like h comma k is your vertex. So that's what is meant by k, that there. Y such that y is an element of the real numbers, y less than or equal to k. So which one of these applies in this one? It depends whether it opens up or down. Does this one open up or down?
This one's going down.
Down. So it's this second one here. And the k value, the vertex is h comma k. So this is h, this is k.
Okay. Yeah, okay. Yeah,
You get that? Is that okay?
yeah.
All right. Let's do one more factoring, I guess. See if you can find one here that is somewhat short. Let's look at 8. And or did we do 8 already?
I think we already did it. Or
Yeah.
sounds a bit.
Let's do 7. I think 7 is prime. So we'll talk about that for a moment here. Okay, so 8 times -10 is -80. Okay. And then let's see here. So we're trying to figure out something that's 5 apart. So if we start writing all of these, it's like -1 and 80, 1 and -80, right?
Mhm.
Those are too far apart. They've got to be 5 apart. That's that -5 apart. So that's where you kind of have to like maybe be a little bit more selective, like maybe start in the middle, like -8 and 10. How far apart are those? They're 2 apart, right?
Yeah.
So those are better. So then maybe say, okay, well, what's the next one? Well, like does so 16 works? So like -16 and 5, 16 and -5. But is there anything in between 8 and 5 that works? Like does 9 work? Does 10? I'm sorry. Does 6 work? Does 7 work? I wrote these poorly.
For
Like, does anything between 5 and 8 work? Because these are 2 apart, these are 11 apart. Like,
yeah, or 6 and 15.
yeah, see, we're trying to find something that's 5 apart. These are like when you add these up, you get -11 or +11. Here you get -2, you
I
get
don't know why I
+2.
wasn't like thinking that.
Well, it's because this is kind of confusing. But when this doesn't work, this for sure doesn't work.
Mhm.
So
Then
it's like,
non-prime,
so then this one is prime.
and it's non-factorable, is what you said.
Yes. But it may be true that even if you find one of these that works, it doesn't necessarily guarantee that this rest of this will work.
Mhm. It
so
has to all go together.
you have to get all the way through the steps there.
Okay.
Okay, so good lesson today, Zach. Appreciate you scheduling, and I hope this helped. I will send
Yeah,
you
this
the.
helps a lot. I don't know what I'd be doing without you, to be honest.
Well, you're doing the hard work. You're going to class every day. Keep on doing that. I bet your grade's great right now. If it's not, we'll keep working
Yeah,
at it.
thanks to you.
All right, I'll send you the notes out shortly. Thanks so much. Have a good night.
All right, you too, Matthew.
Bye
Thank
now.
you.